I can hear you.
Bu Ani? Oh, okay. Okay, everyone, I will, because Bu Ani have something trouble technique, so I will take over for this session. You can hear my voice clearly?
Yes, Miss.
Yes.
Okay.
Yes.
Okay, thank you. Wait, okay. Yes. This morning we will hear guest lecture. Yeah. From my professor. For the firstly, I will introduce myself. My name is Nelly Marlina. I'm a PhD student in Chung-Yuan Christian University, and today my professor will give us guest lecture about emerging contaminant. And okay, hello Bu Ani.
Okay, I'm sorry. Sorry, I have a small technical problem. So
Okay, you can continue, Bu.
Okay. Thank you very much. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alamin wassalatu wassalamu ala asrofil anbiya'i wal mursalin sayyidina Muhammadin wa ala alihi washabihi ajmain amma ba'du. Good morning to our respected speaker, Professor Zheng Jijiang, and also Environmental Engineering Program faculty members, or students, and all of participants of this guest lecture. I'm Ani Juliani, and I'm speaking on behalf of the head of Environmental Engineering Department of UEE, Dr. Eng Awaludin Nurmianto, who apologized as he cannot join us today due to other obligation. So firstly, thank you to Professor Zheng Jijiang for your willingness to donate your valuable time in the weekend for giving us, our students, a lecture on this very important yet challenging topics of emerging pollutant, its health and environmental problem. So Professor Zheng Jijiang is from the Advanced Environmental Ultra Research or Adventure Laboratory of Chung-Yuan Christian University, or CYC, Taiwan. So present here in this guest lecture, students from 3 classes. So from environmental engineering risk analysis, environmental toxicology, and epidemiology and fundamental of sanitation, and many more, as it is often for all of our students. So to my students, please utilize this valuable opportunity to ask questions during Q&A session after the lecture. And to Professor Jiang, may this occasion become the good initiative for collaboration of our institution in the future. And then next, I will give again the screen to Ibu Nelly, who will be moderator for the guest lecture today. So again, thank you very much, Professor Jiang, for your willingness to give us a lecture. And thank you very much for everyone. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi wabarakatuh.
Okay, thank you very much, Bu Ani. I think we will be continue. The firstly, Assalamualaikum warahmatullahi wabarakatuh. Today we will hear my professor to give a guest lecture about emerging contaminant. The firstly, I want to introduce my professor to you. Professor Cheng Jie Chiang, or we can call him Professor Chi. He is a lecturer in Department of Environmental Engineering, Chung Yuan Christian University. He got his PhD in Department of Marine Environmental and Engineering, National Sun Yat-sen University, Taiwan. And Professor Chi, professional in contaminant of emerging concern and persistent organic pollutant and chemical fingerprint and microplastic. Because we have a short time, so we will please for Professor Chi to give guest lecture today. Hello, Professor.
Yes, okay.
Okay. You will share the PPT?
Yeah, I will share my slides. Wait.
Okay.
So is this already?
Yes, Professor.
Okay. So I probably will start. And first of all, thank you, Nady and Annie, for the invitation for this guest lecture in the UII online. So today, this is the topic because I already discussed with Nelly. So she wants me to share some knowledge on the emergent contaminant. Although the emergent contaminant, they have so many type of pollutants. This time, we just focus especially on the pharmaceutical and the personal care product. So we are going to talking about the pharmaceutical. We usually have some abbreviation for pharmaceutical and personal care product, as we call it PPCPs. So this kind of the PPCP, we want to focus on the environmental problem and health. So okay, so before we start, I just briefly just introduce myself for my research interests. Because Nelly already introduced me for where my institute, and our lab focus on two things. The first thing is emergent contaminants. So we especially choose two targets. One is the PFAS, like the PFOA, PFOS, which we also know is kind of the forever chemicals in the world. The other target is now Nelly also focused on her thesis is the organophosphate ester, OPS. These two emergent contaminants, they are all quite new pollutants in the environment. So we want to know their environmental fate and also their potential risk in the natural water environment and the atmosphere environment. So we are not only focused on the water, but also from the air. The other issue is the microplastic. So the microplastic, we focus on several things like how many microplastic in the water. So and where they come from and where they will go. So not only focus on the river, but also from the lakes, reservoir, and the wastewater treatment plant. The other issue, we also focus on the airborne microplastic. So we want to know, because some microplastic is too light, so they can be resuspension to the air, then followed by the long-term transportation to the other location. So we can see how airborne microplastic in the environment, how they disposition and transport from the other site. Also, one of my students, which she is also come from Indonesia, and she already graduated last year. So she also focused on the impact of aging and wearing process on the microplastic, because we can imagine the microplastic in the real world it will be go through the natural impact like the sunshine and the rainfall and the wave to destroy the whole microplastic body. So we want to know if under this kind of the natural process, will they change their suction behavior for some environmental pollutants such as the pharmaceutical and antibiotics. Okay, that will be our research interest in my lab. So let's go to the main topic. So before we begin, we want to let you know what is emergent contaminant. Also, we use the abbreviation usually is ECS. So emergent contaminant, they include several things, like as we already know, like the pharmaceutical, personal care products, and maybe some antibiotics you already knew. And also there's the other kind of the emergent contaminant, like the fire retardants, such as the traditional one is PBDEs, and the new one is OPEs, which I just mentioned before. And there's also some like the forever chemical, like a fluorochemical, PFOA, PFOS. This kind of chemical also emergent contaminant. Also some endocrine disruptor or some electricity drugs. So here's some example for you know, like the pharmaceutical, we have like the antibiotics, caffeine, lipid regulator, or the non-steroidal anti-inflammatory drugs, NSAIDs. For the personal care product, like we can imagine what we use most in our cosmetic product, like the UV filter for your sunscreen lotion, or the fragrance you use every day. And for the electricity drug, which is very notorious for this kind of drugs, like the cocaine, ketamine, amphetamine, and heroin, this kind of drug also can belong to the emergent contaminants. Okay, this is the picture from the US EPA. They just use this photo to explain how the origins and fate of PBCP in the environment. So we can see in our daily environment, a lot of the facility can be the source of the PBCP, such as like the wastewater treatment plant. This is kind of a huge major source to the environment. Also from our daily life, like the wastewater from our home, when we use the toilet, when we take a shower and flush the wastewater, so they will direct it into the pipeline, go into the sewage system, and then eventually go to the river or marine. So if we look at the simple flow rate, so we can see this is kind of origin of emergent contaminant along the river. So we can see usually along the river, probably from the upstream to the middle stream to the downstream. So they probably have some like the industrial compound, which some kind like probably is the pharmaceutical industry. They will make some pharmaceutical. So in this company, in this kind of the industry, they can produce the wastewater, which contain high concentration of the PBCP. Also from the daily drugs we took, the medicine we took in our houses, and when we finish or when we did not finish, we will discharge this kind of unwanted medicine into maybe the toilet, so they can be flushed into the river. And also the municipal wastewater treatment, which I mentioned already, and also maybe some clinic. They probably also use a lot of the pharmaceutical and antibiotics. So when they use it, and maybe their wastewater also have the high concentration of the pharmaceutical and the personal care product. And also some husbandry area, which if we have the animal farming, like the cow, the sheep, the lamb, they probably also will use some antibiotics to prevent some disease. So if we use the antibiotics in this kind of animal, usually when they have the feces or the manure from this kind of animal, and the wastewater will discharge into the river also contain high concentration of the antibiotics. And eventually, this emergent contaminant will go through along the river, then go in the end to enter the sea. So the sea, the marine, we can see it's kind of a sink for this kind of the emergent contaminant. So there's some photo like in our house, daily house, we will use from taking a shower, the wastewater will be contain a lot of the pharmaceutical and personal care product. And this is a very famous picture, which is from 20 years ago, 2000. At that time, the first researcher, which is the Dr. Dalton, he is from the United States and he focused on the PBCP at that time. So he just give the people the concept how the PBCP enter into this world. So they probably will have the two simple ways. The first way is the medicine we eat every day, and we can have some digest, and maybe in the end, we probably cannot 100% digest all of the pharmaceutical medicine, right? So it has to be some part of the medicine will discharge from our body. So the medicine we eat, and then probably some part of the medicine will discharge from our body, then go into the toilet system. The other way is maybe there are too many medicine which we cannot eat. So what in the old time, what will people do to deal with this kind of the unwanted medicine? Usually it will be easy, right? Because medicine usually can be dissolved in the water. So they just say, hey, why not just throw it away into the toilet? Then when the medicine go to the toilet, and they can dissolve in the water. So then it can be easy to treat this kind of medicine, unwanted medicine. So again, this is the other sources. If we just throw the medicine into the toilet, then it will contain the high concentration of the pharmaceutical, then again into the high sewage system. So this is the two pathway for the emergent contaminant. And also, when we say like the antibiotics, it's kind of a huge part of the PBCPs. They use a lot, not only in the human, but also in the animal, like the husbandry area. So when we have the husbandry farming, no matter what kind of the animal you have, usually people will have some, maybe give them some medicine, including the antibiotics, just in case they cannot be sick or get any disease, right? So this kind of the antibiotics, again, like the people, they cannot 100% digest. So will be some part of the antibiotics will discharge from this animal and into the wastewater. So this is the other point source for the pharmaceutical and the personal care product. And this is the poster made in the United States. You can see at the time, they just teach people how you deal with your unwanted medicine. So if you have unwanted medicine or medication, don't let you get away. So don't flush down toilet and drain. We just don't need you to throw it into the toilet. What we can do is we can properly dispose or recycle this unwanted medicine. So as you can imagine, right now almost in every hospital, they usually will set up the recycle station for this kind of the unwanted medicine. If you have too many medicine which you don't already need them, you can take this medicine to this recycle station and give them. They will do the rest, the other treatment for you. So this is the properly dispose or recycle it. Okay, so this is kind of the message from the US EPA at that time. And this is the comic, which is described how serious of this kind of the medicine problem in the United States. We can see this is a very old female lady. So he just grabbed a glass of water. He want to open the tap water to have some drinking water to drink. But you can see in this comics, when she open the tap water, there's no water coming out, only a lot of the medicine. This is the medicine. So a lot of medicine come out. So what it means, because it means you can see the newspaper she had, the prescription drugs found in tap water. That means at that time, because PBCP was so many and have high concentration in the water environment. So even in the drinking water, they also can be detected a lot of them pharmaceuticals. So they just use this comment to reflect the reality of the real world. So at that time, even in the drinking water, you can have a lot of the high concentration of the pharmaceutical. Then the jackpot, I don't know if you know this meaning. The jackpot is because the jackpot usually this term will use in a casino. Like if they have one machine, just put your coin and you have the start the button, and if you get like this, you get the first prize, like you won the first prize, you will usually the people will shout at the jackpot, like you win the prize. Yeah, this is kind of because in the medicine in the United States, it means like you need prescription, right? Prescription drug you will need to buy from the pharmacy, then you need to pay. So the medicine, in the other way we see it, is kind of the money. So you can see if there are so many medicine coming from the drinking water, this means you will have a lot of the money from the drinking water because the medicine is equal to the money. So that's why the female lady just say jackpot. It's kind of like she win the first prize. And this is the other comment from the Nature Journal article in 2006. We can see the comment just, we can see one patient and one doctor. And the doctor just tell the patients, say, take 3 times a day. This means this medicine. You just take 3 times a day, or you can just drink the local water. It means like either you take the medicine directly, or you can just drink the local water, because the local water also contains the medicine. So it's also the other way to reflect the medicine, the high concentration in the drinking water. Okay, what we said already so many, so we need to know why we need to concern this kind of the pharmaceutical and the personal care product. So here is some reason. The first one is because there are so many studies already document that widely occurrence in the exists of the pharmaceutical in the feces, medical waste, or wastewater treatment plants, river, and groundwater. And also in the conventional wastewater treatment process, they cannot efficiently to treat the PBCPs. So that's why usually if we have high concentration of the pharmaceutical in the wastewater, when they go through the wastewater treatment plant, through the whole treatment process, probably the removal efficiency probably maybe 50% or maybe lower. So it's depend on the compound. So it's kind of the conventional wastewater treatment process, they cannot remove this kind of emerging contaminant. And also pharmaceuticals are designed to be biological active at a very low concentration, because you can imagine when we take the medicine, even just one pill, it's maybe just a very low concentration. They can have some impact in your body to treat your sickness. So they are designed to be very active at a low concentration. So even small amount of the pharmaceutical in the environment, they can produce a lot of the impact to the ecology environment. And also pharmaceutical and medicine, we are very used a lot, and so many extensive and long-term usage for the human therapy, description, drug abuse, and veterinary medicine, or even plant agriculture and aquaculture. They also use a lot of the antibiotics. So this is kind of, you have a lot of the continuously usage, so they will produce a lot of resource in the environment. Also, the final is there are lots of reports to this negative impact to the aqua life. Okay, so I think then this is the briefly introduced for the emerging economy for the PBCP. So I just share some of my previously work focused on the PBCP in the environment. So at that time, we just take some water from the rivers, from the wastewater treatment plant. We want to know how many concentration they have in the wastewater treatment plant. So we actually want to know the reality, the PBCP in the river and the marine environment in Taiwan. So we just design this work. Okay, so this is our target compound. We just select maybe 26 or 28 compounds. So we just divide it into different types. So we have the NSAIDs. This is non-steroidal anti-inflammatory drugs, which is very familiar to us. It's like acetaminophen. Acetaminophen is like a Panadol. Like if you take, you can buy easily in the pharmacy. If you have a headache or you get a cold, or you have a fever, usually you go to the pharmacy. You can buy this kind of medicine very easily. So this is the very frequently used for the human, the acetaminophen. Also diclofenac, ibuprofen, ketoprofen, naproxen, salicylic acid, codeine, this kind of drug, medicine they use to treat the, as we know, painkiller. So they can reduce your pain from the body. So usually they use a lot in a daily life. Also, there are several antibiotics we choose for the target compound, like the ampicillin and sulfonylurea, tetracycline, azithromycin, cephalosporin. This is a very famous antibiotics in the environment. And also we investigate two blood lipid regulators, like the sulfuric acid and the gibberellin. And also we also focus two special drug which to treat the psychology issue. We call it carbamazepine and the fluoxetine. Also we also focus on two UV filter, which is benzophenol 3 and benzophenol 4. And also we include for the first time some illicit drug like the amphetamine, methamphetamine, cocaine, heroin, ketamine, pseudoephedrine, cannabidiol, and MDMA, GHB, etc. Also some daily use like the pharmaceutical we will have, like the caffeine, atenolol, and omeprazole. So this is our analytical procedure. So we are not going to very detail. So I just give you an idea how we analyze the pharmaceutical in the sample. So first we will do the filtration, then doing the soil phase extraction. Then in the end, we use the LC tandem mass to analyze the different kind of the pharmaceutical and the antibiotics. Okay, so let's see the first result in our past study. So in the marine environment, so at that time we just take some seawater or marine water sample from the coastal area. So you can see this is Taiwan. We just take the sample from the very southwest Taiwan. So around, if you've been to Taiwan in the south, maybe the big city is Kaohsiung city and the Tainan city. So we just along the coast, we set out like the around 23 sampling sites. So from the very north of the Taiwan coast and going through the Kaohsiung and to the end of the Taiwan. So along the coast, they have a lot of the river just flow into. also as shown in the map, there are so many rivers flow into. So the river can be a major pollution source for the emerging contaminant into the sea. So we have the different river, and also in the orange color, it means the husbandry area. In the southern Taiwan, we have many husbandry areas. So there are two famous husbandry areas just along the Gaoping River and the Urban River. So also two cities, Kaohsiung City and Thailand City, which with the very high population density along this coast area. So we can imagine before we have the detection, we can suspect maybe along the city center, they usually will have a high concentration for the pharmaceutical because the human will bring the impact for the pharmaceutical, right? Also for the husbandry area, probably they can produce a lot of antibiotics concentration. So let's check out if what our assumption is correct or not. So there are also 3 ocean outfall just along the Kaohsiung City. So this ocean outfall can be the other sources because the ocean outfall is just the endpoint for the wastewater treatment plant. So this is a very important thing we should know because they probably produce high concentration of pharmaceutical. Okay, so we can see even in the coastal water, there are still certain emergent contaminant can be detected in a sample. And in there, we can see 4 NSAID sample like acetaminophen, ibuprofen, ketoprofen, and codeine, and 3 antibiotics like the ampicillin, azithromycin, and sulfasen, and also the elastic drug, which we can also detect in the coastal water, which is ketamine, paclitaxel, amphetamine, and MDMA, and also a lot of the human usage, the ingredient like the coffee. Also, the acetaminophen and coffee and the pseudoephedrine they can be found in all seawater sample because we use a lot like the coffee. They contain in our daily life like the coffee we drink, or the Coca-Cola also contain the coffee, or the tea also contain the coffee. And the acetaminophen also we use a lot in our daily life because if you take the medicine for the cold or for the fever or for the headache, usually this is the best one you will choose. And the antibiotics, ampicillin is the high concentration which we detect in the seawater reach to the 88.7 nanogram per liter. Okay. If we look at the different coasts from the north to the south, Thailand coast, Kaohsiung coast, and the Pingtung coast, we can see the average concentration. As we suspect, the Kaohsiung coast have the high concentration of not only the pharmaceutical but also the antibiotics. So we can see they have a positive correlation with the concentration between the pharmaceutical concentration and this one is population. So the more population you have, the more emergent contaminant concentration you have. Okay. So if we look at the composition profile along all of the station, we can see acetaminophen, the dark color, we can see they exist in all of the concentration. Also, the caffeine, the green color, also exist in all concentration. But what we need to notice is the dark red color or the brown color. This is ampicillin. This is the antibiotics, which only have high concentration in some special area, like in the Thailand and Kaohsiung. If you recall, these two area is what we say with the husbandry farming area. So this is the reason why they have this so high concentration of ampicillin in this area. But in the urban area, we can see the Thailand city and the Kaohsiung city. We can see all even close to the ocean outfall. You can see they have in total, the pharmaceutical concentration is very rich to high. So this is the high concentration area is near close to the urban area. And we just use some analytics tool to help us to identify the source. So one of them is we use a lot is the principal component analysis, PCM. We use the PCM to see how they can be separated by the station. We can see they can be separated by two different impacts. One is a human medicine, the other way is a veterinary medicine, which is used a lot of the antibiotics in a husbandry area. So we can see these two medicine, they can separate some station. So we can see in some Thailand station or in some station from Kaohsiung, they can be separated or maybe concentrate in some group. So they can be some anthropogenic impact from the human usage. So this is the reason why we use it to identify this kind of impact. And for this kind of station, which has some high concentration of antibiotics, we can point out they can be the anthropogenic impact by the animal husbandry impact. So this is the group we said. Okay, we also do some potential risk assessment. So here we use the ecological risk. We use is risk quotient. We can calculate it from the measure environmental concentration and the predict non-effect concentration. And the guideline for the risk quotient is when the risk quotient is more than 1, it means high potential risk for the adverse effect. If they just between 1 and 0.1 is a medium potential risk. If between 0.1 to the 0.01 is low potential risk. If the risk quotient is smaller than the 0.01, it can be indicated that no significant risk for the ecological environment. So this is the seawater what we have and their risk quotient. So we just mark the 1. This is the 1. Okay, if the concentration higher than this line, this means high risk. This is the 0.1. This is 0.01. So we can separate in the high risk, medium risk, minimal low risk, or and no risk at this area. So we can see most of the compound is below the 0.01, so with no risk to the ecological environment. But some of them are located between the high risk and the medium risk. So especially for the codeine, ampicillin, and azithromycin, this is 2 of famous antibiotics in the environment. So they have probably reached the medium or high risk. And we can see if we look at the geography for these 3 compounds, codeine, ampicillin, and azithromycin, we can see the red one means they have a high risk. Orange one is the medium risk. The light blue one is low risk, and the dark blue one is no significant risk. We can see for the codeine, almost every station have a risk, just between the low risk and the medium risk. Only the K12 near the marine outfall, they have a high risk. For the 2 antibiotics like ampicillin and azithromycin, most of them have in the dark blue color, show no risks. But for some station close to the husbandry area, they have like a medium to the high risk. Okay, this is the situation what we have in Taiwan for the seawater. Let's go to see the next study. Is kind of an impact from the youth festival. Here we can define the youth festival is the music activities. In Taiwan, we have a special event we call the Spring Screen. It's kind of an outdoor music festival. Usually will organize in every year, like in the early April, in the same area in the south of Taiwan, we call the canteen. And then this contain a variety of the musical style from the bands, both from the Taiwan and the overseas. So usually at this time, there are so many musicians, they will go into this area to have some kind of musical festival. And at this time, based on the calculation data, there will more than 600,000 tourists at the same time during the period of the spring spring. So you can imagine, we can see the photo. Not only the beach, but also the hotel, they were full of the tourism. So it's kind of the huge impact from the human beings. So we just want to know, is there any emergent contaminant impact from the human being during the spring spring, during the youth festival? So we just focus on the Kenting. Kenting is in the south of the Taiwan. So we can see in the Kenting, we just take the sample from the wastewater treatment plant and also from the river near the Kenting. And we also take some sample from, because usually for the neighborhood of the Kenting, usually they also will be the hotel in the neighborhood will also be full of the tourism, because just in the Kenting there's not enough hotel for the tourism. So usually the tourism will go stay in around the Kenting. So we just take the river water around the Kenting also to check if there is high concentration of the pharmaceutical and the personal care product. Also importantly for some illicit drug, because the spring spring was very notorious by the drug abuse issue. So usually when the spring spring, there were some drug dealer, they will go to this event and sell the drugs like the amphetamine, or the party drug to the young generation. So this is kind of the other issue we have in the spring spring. So we also want to check if they have this kind of the high concentration of the illicit drug. Okay, so this is two wastewater treatment sampling location we have from along the Kenting. And the result shows 23 emergent contaminant was detected in the river water and wastewater. So that includes seven NSAID, the anti-inflammatory drugs, and 4 antibiotics. And what a surprise is they have 6 kind of the illicit drug which contain amphetamine, methamphetamine, ketamine, pseudoephedrine, FN2, and MDMA. FN2 and MDMA is kind of the party drugs. So we can find this illicit drug concentration in the river water or in the wastewater treatment plant. Also, some very common like caffeine, carbamazepine, extate, dimethyltryptamine, ethanol, and BP4. So this is 4. Also, we need to notice there are 4 compounds which were observed in high concentration, maximum concentration exceeds more than 5,000 nanogram per liter. This means like 5 ppb in the environment. This is ketamine and the pseudoephedrine. This 2 is from the illicit drug, which they have a high concentration, like 138,000 nanogram per liter, and 44 and 667 nanogram per liter. And the coffee, of course, they're high, because as long as you have tourism, they probably will bring a lot of coffee because of the coffee, the tea, the drinks they have. Also, the painkiller, we have the acetaminophen for the 6,700 nanogram per liter. Okay, so if we look at the river water, we can see in different time long, like the off-season. And because in the Kenting, usually is very hot, they can separate the off-season and the peak season. The peak season usually is the summer vacation. The off-season is kind of in the winter. So usually a lot of people will go during the summertime. So we can separate from the off-season in October and the dry season in March, and the spring spring, the youth festival, the special issue event in April, and the peak season in August. And you can see this is the number shown here is the rainfall amount. So you can see in the wet season, they indeed have received a lot of the raining water, like 1,000 millimeter, but in a dry season, just 5. So the dry and the wet season is quite a difference. And we can see the concentration. So we can see we need to notice the YSL, the unit is different. So even the bar things look similar, but the YSL is different. This is 5 off season. The concentration is just low, or below less than 5,000 nanogram per liter. But if you see the dry season or the peak season or the spring screen period, you can see the pharmaceutical concentration will reach more than like the 10,000, 20,000, even 40,000 high. That means the concentration getting higher and higher during the youth festival, especially for the special event. Okay, so let's see. Also in the wastewater also show a similar trend. If we see the wastewater from the wastewater treatment plant, we can see the wastewater infant and effluent. Especially for the infant, during the youth festival, the concentration can reach like 118,000 nanogram per liter. You can see this is very high, especially for this kind of the great color is the NSAID and the illicit drug. And then if we look more detail during the period of the youth festival, we can see how interesting the concentration variation from the beginning and during the event, and then after the event, the concentration can go very smoothly going to up and maintain then going down. So in the stage 1, we call the weekend beginning before the spring screen. So the concentration usually still at a low concentration. And when the stage 2, the spring screen begin, then the tourism just involve and get into the canteen area. So the high concentration just showing out, and the concentration was increased. And in the stage 3, it's like during the spring screen. So the concentration will maintain at high concentration. And the stage 4 is end of the spring screen. So when the tourism just vanish, they just go away, go home. So no more tourism in this area. So the concentration will decrease and back to the stable from the background level. So this is how the weekly pattern they have. And this is the compositional profile like we have. So because the time, so we just go through, we can see for the wastewater treatment plant, they have a lot of the electric drop pattern for the orange color. And for the background, the color, they just have the yellow, the blue color, which is the anti-inflammatory or the antibiotics. Okay, so we also use the PCA to identify the sources. So we can see, again, we can separate the 2 different sources, but this time it's not the husbandry area. It's all the human medicine, but in different way. One human medicine is regular one, daily medicine we took, like the NSAID and antibiotic. The other human medicine is like the tourist impact, like the illicit drug and the coffee. So we can see during the youth festival, we can see the huge tourist impact, especially in April. Like we can see in this group and this group, we can see a lot of the illicit drug input and coffee input. And then the other way around is here for the off season. There's no tourist impact, so the group is very stable just in this corner without any like antibiotics, NSAID or illicit drug. And when we look at the wastewater treatment plant, we can calculate their mass load input into the environment. We can see the weekly input from here to here. We can see weekday just have a similar trend with the concentration. So from the beginning, they have slow mass input, but when the spring screen beginning, so the input loading was getting higher And when finish the spring screen, the loading will back to the background level. And also for the seasonal input, we can see in the spring screen, the input load, the units, how many gram per day they can be discharged in the environment. The spring screen is very high, as far high from the peak season, dry season, and off season. Okay, this is the trend we have. So we can calculate like during the spring screen, you can calculate like every person they can produce 0.56 milligram for the emergent contaminant contribution to the environment. So this is a very high, and this is annual input. If we counting by different compound, we can see the pseudoephedrine compound, they can every year they can produce 5,170 grams, and for the ketamine they probably can produce 3,000 per year, and the acetaminophen they can produce like 60 or 1,600 grams per year, and the coffee is like 877 grams per year. Okay, so this is the input we have, and this is the other way we want to develop and approach to analyze the pharmaceutical. We want to call the pharmaceutical signature. We use several river water sample in the Kaohsiung from different area, urban area, rural area, and husbandry area to identify their potential sources. So we just see how many concentration they have, and we can see the concentration, the valuation from the different sample location, and we can see why they have a huge high concentration and sudden decrease because of the interception station located, so they can cut the river water, and so the high concentration will decrease suddenly. Okay, so let's go through, and we just see the relationship between the human medicine and the antibiotics concentration in different river. So we can see they actually do some have the correlation. So that's why we use a reset model to develop the source contribution in not only for the husbandry area, but also for the urban area, to see how many contribution from the human or from the husbandry. So this is our result. We can see different river. We can see three source contributor. One is the domestic impact. The second one is antibiotics application. The third one is drug abuse. So in the river water, we can separate them, and we can see how they have the domestic in different areas. So the black color is the domestic impact, right? So in a lot of the river station is coming from this domestic impact, but there are some from the gray color, light gray, FS2. This is the antibiotics application. So there are some stations they have this kind of that means this station is close to the husbandry area, so they have the impact from the husbandry area. And most importantly is the FS3, this dark gray color, especially in some specific station. This is the kind of drug abuse station. So this is in the urban area. So sometimes probably in the urban, there's some people will use the drug abuse in that. And if they discharge in a toilet, the river will receive the effluent from wastewater. So we can see reflect the impact. So we also use the other analytical statistical analysis we call HCA. The HCA also can help us identify different sources. So we can see the two classes. We have the class one, we have a high composition of the caffeine, which is here. And also in the different river, they have a lot of the density population area. So they have high concentration of caffeine. For the class two, this is from the composition of the ampicillin, which is, we mentioned before, this is from the husbandry antibiotics area. So we can see in some river, they flow through the husbandry area, they have this kind of high concentration of antibiotics. And we also apply this in different rivers. So we just take a river from the central Taiwan and the southern Taiwan in two big cities, Taichung and Tainan. in different water. So we can see two major different city. We can see their different concentration variation. So again, for the because they also in the urban area, so asset non-stereo as NSAID and the coffee will be the major contribution for the environment. And also from the some river, they probably have the go through the close to the husbandry area. They also have some antibiotics impact. So this is the composition file we use, and also use the calculate their mass flux into the river. How many pharmaceutical they can be input into the river. So we can see in south and the central water system, there are so many different. So in the drain system, which is the white bar, we can see they produce a lot of the coffee and the acetaminophen, because this is the drain system within the city center. So they can produce a lot of the human input. And the yellow is the antibiotic, the ampicillin, which they produce a lot of the mass input in the Zhuoshui River, which is very close to the husbandry area. So we also apply the pharmaco signature to see different sources. We can see the coffee and the illicit drug, and also some from the density population area, also some husbandry area with this kind of the ampicillin. Also use the PCA MR to see how the domestic input, antibiotic application, or drug abuse in different river, different area. Okay, so in summary, because time almost there, so we just investigate the all kind of the water environment in Taiwan, including the marine water, river water, and the wastewater. So we can see different water systems. They have different pharmaceutical and personal care product pattern. And also we can see a lot of the strong elements. So in the wastewater treatment plant. So this is probably how we see how many input they can be produced into the river water or to the marine water. Okay, this is summary. So again, we want to thank for the National Science Technology Council for the financial support. And there's also, especially when I need to thank all the members from our lab, which for provide all the assistance and the field sampling. And this also just some advertise period. So if we are opening for the master and PhD program, if someone which is interested in study in Taiwan, we are really welcome. We are hiring. So if you have any question, you are very welcome to contact me or contact the Brunelli, so she can arrange any following process. Okay, thank you so much.
Okay, thank you very much, Professor JJJ, for your wonderful presentation and very detailed presentation. Okay, for the next, we will continue to question and answer Q&A. Please, who will have a question, please raise your hand, or you can type the question on the comment. There is any question?
Yes.
Okay. Yes. Wait. Okay. Please, Miss Rina Yani Alia.
Okay, thank you, Miss Nelly. Thank you for the opportunity given to me to ask Professor GGG. Previously, let me introduce myself. I am Isrina and I'm from Taiwan as a Prof. GGG student. I feel very interested in the topic of emerging pollutant. I have some questions. If they are emerging pollutants spread throughout the world, especially microplastic pollutant, which we know are difficult to decompose and difficult to react with, they can only be broken down into micro to nanometer size. What are the actual disadvantage and impact of microplastic on human when compared to the other pollutant? And the second question is, can we remove or reduce microplastic in the environment, and how to do it? Can plants be used as bioremediation for microplastic like heavy metal pollutant? And the last question is, in the process of burning plastic, can microplastic also be released into the environment, especially into the air? That's all my question, Miss Nelly. Thank you.
Okay, thank you very much for Miss Yani. Please, Professor.
Okay, I just wondering who she is. Oh, it turned out she's my student. Yeah. Okay. So for the first question, so the microplastic. So what kind of impact microplastic will do when enter the human body? Because we can see the microplastic. So because the microplastic is so small, it's kind of the micro or nano size. That is kind of a very small particle. You can imagine it's kind of a small particle like the PM 2.5. So this small particle, they can actually they can on their surface, they can absorb the pollutant, all kind of the pollutant, like the heavy metal, dioxin or emergent contaminant. So when the pollutant was absorbed on the surface, actually the microplastic, you can see is as a carrier or a vector to deliver this kind of the pollutant into human body. So in a way, microplastic itself, originally they can have some impact to the human nervous system. If they also contain pollutant on the surface, they can be doubled or tripled the negative impact, because when the heavy metal or the emergent contaminant go into our human body, that can cause some negative impact, like get the cancer or the other health problem issue. So this is the main problem for the microplastic. And then the second problem is how we can deal with treatment or remove this issue. Right now, I think for the microplastic, there are already a lot of the third party to impact or to make some contribution to collect the microplastic in the environment. Here I give you some link. I just paste the link in chat room, so people, you can just click the link. This is the project called the Ocean Clean Up Project. It's led by a young generation, but probably you heard it before. So the people now already, after 2 or 3 years hard working, they already create a device to collect the marine plastic or microplastic. So in the way they want to decrease the environmental microplastic. So probably this is the answer. So I forget, I did not follow your third question. You have a third question?
I think the
Sir.
second question, can we remove microplastic from the environmental, and how do it? Yes, Miss Yani, that's right.
Yes, that's right, Miss Nelly.
Okay, then probably always it. Yeah.
Okay. Another question? Who? Please raise your hand.
Here.
Yes, please. Who? Oh,
Excuse
sorry.
me, Aisyah Intariski, Bu.
Okay. Yes, please.
Such as the concentration of pharmaceutical found in drinking water supplies. From the explanation that has been given, I would like to ask, what are what are the challenges and opportunities for developing new antimicrobial resistance control approaches, wastewater management besides costs involved? Thank you.
Well, so for the antibiotic resistance, right? So I think this is the most issue for the antibiotic resistance gene, yeah, because this is now very the other hot issue for the emerging contaminant, because as we know, we already use a lot of the antibiotics in the environment. So usually, the more we use, probably for some bacteria or some virus in the environment, they probably will get used to this kind of antibiotics. So they will produce because they can be involved. So they can be getting resistant to this kind of antibiotics. So I think if someone this will be a very important issue to it. So I also encourage the people, if you want to focus on the antibiotics resistant gene, this is very good for you to do it. Yeah.
Okay, thank you.
Okay, thank you. Yes, there is, I think this is the last question, Professor. Someone text to me. We know paracetamol contaminate water bodies, and what kind of advanced treatment is needed to neutralize, or at least so that water is not dangerous if consumed by public?
So
The advanced treatment.
oh, for the wastewater treatment process?
Yes, yes.
Okay. Yeah, I think the most advanced for the pharmaceutical and antibiotics is the ozone treatment. So ozone, they actually can produce the free radical, and the free radical can actually to decrease the pharmaceutical and the antibiotics in the wastewater treatment. So I will suggest ozone is the most advanced process.
Okay, okay. Thank you very much, Professor. I think that is last question for our guest lecture. Bu Ani, are you there?
I think there is one more students who raise
Oh,
her hands. Maybe
Wait.
Wahda. Maybe you can.
oh,
can you
yeah.
just give
Okay.
her 1 second?
Miss Wahda.
Hi. Okay.
Okay. Please.
Good
One question
morning.
more, Professor.
Okay, so sorry. Good morning, Prof. So, this is really interesting for me. So, I want to know, is there any big problem behind your research? Like in Indonesia, there's a problem that paracetamol in Jakarta Bay affected the shellfish. Is any big like behind problem of your research?
Sorry, I did not follow very well. Can you say again?
Sorry. So, is there a big problem behind your research?
You mean the problem?
Yeah, like in Indonesia, there's a problem like paracetamol in Jakarta Bay affected the shellfish. So we take more research for knowing the contaminant.
Oh, okay. So I think the problem, yes. I think right now, because I think for the pharmaceutical and the antibiotics, I think now probably because this issue already been doing for maybe more than 20 years, right? As I mentioned in the slide in the beginning, the first research doing this is from Dr. Dalton from the United States. At the time it's 2000. Now it's 2023, already 23 years. So I think over these 20 years, I think a lot of the instrument and the technology already been developed. So right now, focus on the pharmaceutical and the antibiotics is not a big challenge. So I think it can be easy to done by any institute as long as you have the equipment. I think the most challenging for our lab is, and also this is the reason why our lab also shift the focus on the other emerging contaminant. We shift focus on the pharmaceutical, but now we already shift our target to the new compound, like the PFAS and the OPES. Because right now pharmaceutical, when you look at the literature or the reference, you can see a lot of the study already been done in the worldwide. But there are so many limit knowledge on the PFOA, PFOS, and even the OPS at this moment. So I think right now, what we want to do is to expand our knowledge on the new pollutants. So this is probably the challenge for us to do it at this moment.
Okay,
Thank you, Prof.
Thank you, Professor, and thank you, Ms. Wahda, for your question. I think this is the last question because we have a limited time. So this guest lecture will be end with Bu Ani.
Okay. Once again, Professor Professor Jiang, thank you very much for a very insightful lecture. Yes, indeed, it is a very challenging topics. Also becomes our concern too in Indonesia. But however, we have some challenges, especially on the laboratory analysis. So we have challenge on laboratory analysis because it is such expensive, and also we have many limitation on instrumentation, on laboratory instrumentation, how to analyze this emerging contaminants. So maybe it will be a good opportunity if we can collaborate in this matter in the future, maybe between our institution, so we can maybe take samples, for example, from Indonesia, but we can analyze in Taiwan, because I think in Taiwan you have a very sophisticated laboratory on this matter. Once again, thank you very much, Professor Jiang, for your time, and hopefully we can have another collaboration work. I think you will visit us also in November next month, so we'll see you then. So thank you very much once again. Bu Nelly?
Okay, thank you very much, Bu Ani, and thank you very much all for your attention and for your question and for your response. And we will end this session guest lecture. Hopefully, we can meet again in another time. Thank you very much for Professor Gigi too for your time, for Bu Ani too, and all student and participant. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you, Prof.
Okay, thank you guys. Thank you. Bye-bye.
Bye-bye, Prof. Bu, izin live ya, Bu.
Ya,
Mau
oke.
Terima kasih.
Terima kasih, Bu. Terima kasih banyak.
Terima kasih ya, Bu.
Ya.
Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh.
Salam warahmatullahi wabarakatuh.